Hi everyone, now what I'm going to do is provide the homework solutions for this review, sections 1 to 5. It basically was from perfect squares, factoring, binomial expansion, Pythagoras, and trig, in other words, solving for the unknown angle. Alright, so let's start with section 1, which was basically on the squares and cubes. So 1 square is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is equal to 100. So the squares of the first 10 numbers should have been easy. The next 10, in other words from 11 to 20, are a little bit hard, but you have to memorize them. So 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. Notice how the numbers flip from 69 to 96, from 13 to 14. And 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And finally 20 squared is 400. All right, so that's from 1 to 20. Now let's do the cubes of the first 5 numbers. So 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, and finally 5 cubed is equal to 125. Once again, these have to be memorized. All right, let's move to section 2, where we have to solve. So, oops, I think I have it wrong here. Let me just do that again. So, the square root of 289 is obviously 17. The second one is 7 squared is equal to 49. The third one is the cube root of 125. So remember, 5 cubed is 125, so the cube root of 125 should be 5. Fourth one is 15 squared, which we've already determined is 225. And the fifth one is the square root of 400, which we know to be 20. All right, let's do number 6. 6 is 3 squared plus 4 squared. What is that? So in other words, that is 9 plus 16, which is equal to the square root of 25, which is equal to 5. Number 7, what is that? So that's 8, the question was 8 squared plus 15 squared is equal to something squared. So we got to find that something. So 8 squared is 64, and 15 squared is 225, which if you add these together, you'll get 289, and we know that 289 is basically 17 squares. So that's something, so the answer is equal to 17. Okay, for number 8, I don't think I have space, so I'm just gonna move to a new page. So for number 8, it's the cube root of 64, which we've already said is 4. So remember, 4 cubed is 64, so the cube root of 64 must be 4. Number 9 is the cube root of 8, which is 2. Remember, 2 cubed is 8, so the cube root of 8 is equal to 2. And finally, for number 10, it's the square root of 361, which we know is 19. All right, so now let's move on to the next section, which is on factoring. I'm just clearly moving my pages here, so that's what you're hearing. Oh, sorry, it's not factoring, it's binomial expansion. So section 3, and we're expanding binomials. Okay, so the first one is x plus 2 squared. Now if you remember the trick, right? Well, I mean, let's go over what this means first. This means x plus 2 times x plus 2, right? We can do it the long, old-fashioned way, but remember the trick that I showed you. Whenever you're squaring a binomial, just square the first term, which is x squared, okay? The middle term is basically the first term times the second term times 2. So in other words, x times 2, which is plus 4x. And finally, you just square the last term, which is 4. Okay? So let's try the second one. Same trick applies here. X plus 3 squared, right? You square the first term, which is x squared. You multiply the first term times the second term times 2. So x times 3 times 2 is plus 6x. And then you square the last term, which is plus 9. Let's do the third one, which is, like, you see the pattern here going. It should be pretty straightforward. But anyways, you square the first term again, which is x squared. For the second term, it's the first term, x, times the second term, positive 4, times 2. So x times 4 times 2 is positive 8x. Plus, and then you square the last term, which is 16. So that's that. Let's do number 4. What is number 4? X plus 5 squared. Again, same deal. X squared plus 10x, right? You multiply the first term, the second term times 2. So 5 times x times 2 is 10x plus 25. Number 5 is x minus 5. Now this is a little bit different. Observe how this is different. See, this was plus 5, and now this is minus 5. So again, we square the first term, which is x squared. Now we multiply 2 times x times negative 5. 2 times x is 2x, and 2x times negative 5 is negative 10x. And then finally you square the last term. When you square a negative 5, it still becomes positive, so we still get positive 25. So observe that between these two, the only thing that changes is the middle term. This is positive x, and this is negative 10x. All right, so number 6, it's x plus 6 squared. So in other words, you take the square of the first term, which is x squared. The middle term is positive 6 times x times 2. So it's 6x times 2, which is 12x. And then you square the last term, which is 36. Number 7, it's basically the same thing now, except it's x minus 6. So like I said before, you square the first term, x squared, and then the second term is 2 times x times negative 6. So it's negative 12x. And then you square the last term, negative 6 times negative 6 is positive 36. Remember that when you square a number, whether it's positive or negative, it'll always end up being positive. And observe once again that this is positive 12x and that's negative 12x. All right, so let's move on to the last 3, which is 8. Number 8 is 2x plus 3 squared. Okay, now let's square the first term. If we square this, 2x times 2x is 4x squared. Okay, the middle term is going to be 2 times 2x times 3, right? So 2 times 2x is 4x, and 4x times 3 is 12x. So we get plus 12x. And finally, we're squaring the last term, which is plus 9. Let's do number 9, which is basically the same thing, except now with the minus sign in between, right? So once again, we square this. What do we get? We get 4x squared, because 2x times 2x is 4x squared. The middle term is 2 times 2x times negative 3, right? So 2 times 2x is 4x, and 4x times negative 3 is negative 12x. And finally, the last term, is to square the negative 3, we get plus 9, and that's our solution. Number 10, it's 3x minus 7 squared, right? Same deal. If we square 3x, we get 9x squared, because 3x times 3x is 9x squared. The middle term is 2 times 3x times negative 7. 2 times 3x is 6x, and 6x times negative 7 is negative 42x, right? And finally, negative 7 squared, when you square a negative term, we get positive, and that's 49. And that's our solution for section 3. Did I call it section 3 or did I call it section 2? Yes, I did call it section 3. Okay. All right, so now moving on to section 4, where we are factoring. Okay, so let's remember how to factor. So x squared plus 5x plus 6. Okay, so I'm going to use the MAN method that I showed you in class. So m stands for multiplication. And how do we get the m? It's the 1 here times the 6 here. Okay, so 1 times 6 is 6. Let's do the a. The addition term is always the middle term, which is 5. Okay, and the n is, now we've got to find two numbers that multiply to 6 and add to 5. the two numbers are clearly 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. Now, what these two numbers here do is basically they just split this middle term, right? So in other words, it's x squared plus 3x plus 2x. Observe how the 3 and 2 are basically this 3 and 2, and they split the 5, right? 3x plus 2x is 5x plus 6, right? Now what we do is we group. We take the first two, and then we take the last two. So what's common in the first two? The only thing that's common in the first two is x. And what's left over is x plus 3. Now what's common in the second part? It's 2, right? And what's left over is x plus 3. And now what we observe is that these two are common. So we put x plus 3, we factor out x plus 3, and what's left is this x over here. And what's left over here? The plus 2. And that's how we factor. And so this is our answer for number 1. Right? Number 2, x squared minus x minus 6. Same deal over here, right? Let's do the man method again. We have a 1 here, we have a 6 there. We multiply these two numbers, okay? So we get negative 6. The addition term is always the middle term, right? In this case, it's negative 1. We don't see a 1 here, but we can assume that there's a 1 there. Okay, and then we got to find two numbers and multiply to negative 6 and add up to negative 1. So the numbers that I can think of are, once again, negative 3 and 2, right? Negative 3 times 2 will give you negative 6, and negative 3 plus 2 will give you negative 1. Once again, we put x squared. This middle term will split, okay? It becomes negative 3x plus 2x. Observe that these ones, again, come from here. Minus 6, okay? Then we group the first two and we group the last two, right? So this is x minus 3, right? What's common between these two? It's 2, right? And then it's x minus 3. If I factor out the 2, I get 2x. Remember, 2x times, 2 times x is 2x, and 2 times negative 3 is negative 6. So that's how we factor that. And then finally, observe that these two are the same, so x minus 3, and then it's x plus 2, and that's our solution. All right, number 3. Let's do number 3. It's x squared plus 6x minus 7. If we go through the man method again, right? 1 times 7 is negative 7. A is the middle term, which is positive 6. And now we got to find two numbers that multiply negative 7, add up to 6. So the ones I can think of are 7 and negative 1. So because 7 times negative 1 is negative 7, 7 plus negative 1 is 6. So we get x squared, right? Remember, this splits into positive 7x minus x minus 7, right? And then we're going to group this, right? Find out what's common between these two. So in the first two, only x is common, and what you're left with is x plus 7. In the second two, if you observe, negative 1 is common, right? Because this is negative 1 here and negative 7. So what do we get? And this is x plus 7. Because negative 1 times x is negative x. Negative 1 times positive 7 is negative 7. Again, we observe that these two are the same, so we can factor that. So it's x plus 7. And then we get x minus 1, and that's your solution. Let's do number 4. Number 4 is x squared plus x minus 12. Same deal as before, right? The multiplication is the first term times the last, so it's negative 12. The a is the middle term, which is the one with the x, so that's positive 1, right? And now we've got to find two numbers that multiply to negative 12 and add up to 1. So the numbers I can think of are 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. Remember again that this splits, the middle term splits. So it's x squared plus 4x minus 3x. Again, these come from here, right? And then minus 12. So then we group the first two and we group the last two. What's common in the first two? In the first one, it's x. So it's x plus 4. And what's common in the second two? It's minus 3. right? And what are we left with is x plus 4. The reason why it's x plus 4 is what's negative 3 times x is negative 3x, and negative 3 times positive 4 is negative 12. We observe once again that these two are common, so it's x plus 4, x minus 3, and there we go. Number 5. It's x squared minus 7x plus 10. Same deal as before. The m is for the first and last, so it's 1 times 10, so it's 10. This is an m, by the way. And the a is the middle term, which is negative 7. Remember, the middle term is always the one with the x, okay? So n is equal to, anyway, we've got to find two numbers that add up to 10, that multiply to 10 and add up to negative 7. So the number ones I can think of are negative 5 and negative 2. Because a negative times a negative is positive. That's where we get positive 10. And negative 5 times plus negative 2 is negative 7. So remember the middle term splits. Okay, so it's negative 5x minus 2x plus 10, right? Then we're grouping the first two and grouping the last two. Okay, so if we group the first two, what's common between these two is simply x. And what we're left with is x minus 5, right? Because x times x is x squared, x times negative 5 is negative 5x. What's common between these two? It's negative 2. And what are we left with is x minus 5, because negative 2 times x is negative 2x, negative 2 times negative 5 is positive 10. All right, so then what are we left with? X minus 2. And observe that these two are the same, so we can, oh, I should have maybe done that. Sorry, let me just move this. Okay, it doesn't really matter, but since those two are the same, it's x minus 5. And what are we left with is the x over here and the minus 2 over here. So this is our answer. Okay, number 6. Now, number 6 is the first one where the first coefficient, the initial coefficient, is not 1. In other words, it's 2 right here. So it's 2x squared minus 3x minus 2. So let's do man is, remember, it's the first term times the last term. So it's equal to negative 4, because 2 times negative 2 is negative 4. The a is the middle term, which is negative 3. So we got to find two numbers, right, that multiply to negative 4 and add up to negative 3. So what I'm thinking the numbers are negative 4 and 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So remember, the middle term splits, right? So we get 2x squared, and then we get minus 4x, which comes from here, minus x, minus 1x, which comes from here. Oh, sorry, it's plus 1x. My mistake, plus 1x. Minus 2. And then we group the first two and the last two. So what's common in the first two? It's 2x, right? And what are we left with? It's x minus 2. Because 2x times x is 2x squared, 2x times negative 2 is negative 4x. What's common here? Nothing. There's nothing common between 1x and negative 2. So when there's nothing common, there is always positive 1 in common, because 1 times anything is itself. So what are we left with is x minus 2. So we get 1 times x is 1x, 1 times negative 2 is negative 2. So what are we left with? Since x minus 2 is common in both, we factor that out. And what are we left with? 2x here, and the plus 1 here, and that's how we factor that one. All right, number 7, it's 3, sorry, it's, let me go here, sorry. It's 3x squared plus 13x plus 4. Once again, we multiply the first two numbers, so the first number and the last number for multiplication, which is 12. 3 times 4 is 12. A is always the middle term with the x, so that's 13. So the two numbers that we need that multiply to 12 and add up to 13 are 12 and 1. So because 12 times 1 is 12, 12 plus 1 is 13. So what do we get here? 3x squared. Remember, this middle term splits to plus 12x because 12 there, plus 1x because of the 1 there, and then plus 4. Okay. Then we're going to group the first two and the last two. So what's common between these two? It's 3x. And what are we left with? Is x plus 4. Because 3x times x is 3x squared. 3x times 4 is 12x. And then again, what's common between these two? Nothing. So when nothing's common, it's just whatever sign is here, so it's plus, and 1, right? And we're left with is x plus 4. Because 1 times x is x, and 1 times 4 is 4. We observe that these two are the same, so we get x plus 4 over here. And then what's left over is the 3x over there, and then plus 1 over here, and boom, we're done. All right, let's continue with number 8, which is 2x squared minus 9x plus 4. Okay, so remember that the first and last terms get multiplied, which is what the m stands for, so that's 8. A is the middle term that has the x, so in other words, it's minus 9. So two numbers that multiply to 8 and add up to negative 9 are negative 8 and negative 1. So the middle term will split, as we said before, so that's 2x squared minus 8x minus 1x plus 4. That's equal to 2x squared. Oh, sorry. Let me just go back here. So now what we're going to do is we're going to try to group the first two and the last two. So what's common between the first two is 2x, and what we're left with is x minus 4. And what's common in the first two? It's minus 1. There's nothing really in common, but keep the sign the same one as the negative over here. And since nothing is common, just put 1. So what's left over? It's x minus 4. The reason why it's x minus 4 is negative 1 times x is negative 1x, and negative 1 times negative 4 is positive 4. We observe that the x minus 4 is in common, so x minus 4. And what's left over? We got this 2x over here, we got this minus 1 over here, and that's our solution. All right, let's move on to 9, which is 6x squared plus x minus 2. Once again, multiply the first and the last, so it's negative 12. And a is the middle term right here, so that's just 1. So we got to find two numbers that multiply to negative 12 and add up to 1. So the ones I can think of are 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So remember, the middle term splits. Okay, so we get 6x squared plus 4x, which comes from here, and then minus 3x, which comes from here, minus 2. We have to group the first two and the last two. So what's common amongst the first two, or between the first two? It's 2x. So what do we have left is 3x plus 2, because 2x times 3x is 6x squared, and 2x times positive 2 is positive 4x. What's common amongst these two? Nothing, but keep the same term, same sign as that one over there. And since nothing is really in common, 1 will always be in common. So what we have left is 3x plus 2. Right? Negative 1 times 3x is negative 3x. Negative 1 times positive 2 is negative 2. These two end up being the same, so we factor that out, 3x plus 2. And what's left is the 2x over there minus 1. And that's factored. Now, the last one, a little bit tricky, but it's still doable, is 9x squared minus 4x. Now, we don't obviously, oh, sorry, not minus 4x, just minus 4. Minus 4 right there. Okay, so obviously there's no middle term. So if you observe, we can just rewrite this as 9x squared plus 0x minus 4. So in other words, this ends up being the middle term. Remember, the middle term is the one with the x. If there's no x, it just means it's 0. And now we just do the same thing as before. Okay, so m is equal to, or the multiplication is 9 times 4 is negative 36. A is equal to 0. And the two numbers that multiply to negative 36 and add up to 0 are 6 and negative 6. Remember, the middle term splits. Okay, so we get 9x squared plus 6x minus 6x. These 6's come from here, and then minus 4. We group the first two and the last two. What's common amongst the first two? It's 3x, right? So what are you left with is 3x plus 2. The reason why that is 3x times 3x is 9x squared, and 3x times positive 2 is positive 6x. Again, what's common here is negative 3, right? So we get, sorry, not negative 3, it's my mistake. It's negative 2. It's negative 2. Negative 2 is common. So what are we left with is 3x plus 2. Once again, negative 2 times positive 3x is negative 6x. Negative 2 times positive 2 is negative 4. These two end up being common, and so it's 3x plus 2, and then it's 3x minus 2. All right, so that's it for factoring. Now let's move on to the next part, which was Pythagoras. So section 5, we have to solve for x and the unknown side. So let's start with this diagram right here. It's a right angle triangle. Okay, here's x, here's 7, here's 5. Right, so we can just use Pythagoras. So 7 squared plus 5 squared. Once again, this is the hypotenuse, right? Why is it the hypotenuse? Because it's right across from the right angle. So this is equal to x squared. So that's 49 plus 25 is equal to x squared. That's equal to 74 is equal to x squared. So therefore, x is simply the square root of 74. And that's a solution for number 1. Number 2, we have it like this. Here's the right angle. Here's 3. Here's x. Here's 10. Let me just use a different color. So once again, what's the hypotenuse? Always identify the hypotenuse first. So this is the hypotenuse right there, HYP. So 10 is the hypotenuse right here. So once we have that, we pretty much have our equation pretty much set up. So it's 3 squared plus x squared is equal to 10 squared. So that's 9 plus x squared is equal to 100. X squared is equal to 100 minus 9, which is 91. So x is simply the square root of 91. Okay, number 3. That's number 3. We have it in this way. Here's the right angle. Here's 4. Here's 5. Here's x. So let's identify the hypotenuse to begin with, right? So let's just do this. So again, this is the hypotenuse because it's right across from the right angle. So this is the hypotenuse, HYP, okay? It stands for the hypotenuse. So let's just go back. So once we have that, we know it's x squared plus 4 squared is equal to 5 squared. X squared plus 16 is equal to 25. X squared is equal to 25 minus 16, which is equal to 9. So x squared is equal to 9, which implies that x is the square root of 9, which is equal to 3. And that's our answer. So this is 3. Number 4, let me just flip the page here. Here we go. Here's number 4. So I have this diagram right here. So here's my right angle. Oh, I didn't draw it to scale, but that's okay. X, again, first step is identify the hypotenuse, which is this one right here because it's right across from the right angle. Okay, so when we do that, we know that it's 5 squared plus 12 squared is equal to x squared. So this is 25 plus 144 is equal to x squared. And as we can see, this is 169 is equal to x squared. So x is equal to the square root of 169, which is equal to 13. So x is equal to 13. And our last one for section 5 is this one. Now this one was a little bit tricky, but we will go over it and figure it out. So here's 17, here's 15, and here's x plus 4. Now the first thing is, like I said before, is always identify the hypotenuse. So, and you know it's right across from the right angle, so you know that 17 in this case is the hypotenuse. So what we do is it's x plus 4 squared plus 15 squared is equal to 17 squared. Okay, so let's expand all this. There's actually 2 ways to do it. So maybe I'll do it the easy way first. So I'll do the easy way first. Okay, here's the easy way. Don't expand the x plus 4 squared. Just leave that as is. So, right? But solve for the others. So that is 225, and that is, that was 289. Am I right about that? Yes. No, sorry. What am I saying? Yeah, it is 289. It is 289. So it's x plus 4 squared is equal to 289 minus 225, which is equal to 64. which is equal to 64. So x plus 4 squared is equal to 64. Now if I want to get rid of this, I just square root both sides. So let me just use a different color here. So I can square root this side here, I can square root that side there, and what I'm left with is x plus 4 is equal to 8. Right? And what that means is x is equal to 8 minus 4, which is equal to 4. So if I look at this triangle, this side, so I know that x equals 4, but the side is x plus 4. So in other words, the unknown side is equal to x plus 4, which is 4 plus 4, which is equal to 8. That's right? So this side is 8, but x itself is equal to 4. Okay, so that was the easy way. Let's do the hard way, which I believe a number of people might have tried. So it's the same question. I'm just going to draw it again. So this is x plus 4, 15, 17. We already know that this is the hypotenuse because it's right across, so that's okay. So x plus 4 squared plus 15 squared. So again, this is the hard way. So is equal to, sorry, just going to separate that there, is equal to 17 squared. So a number of you probably tried to expand this. So let's expand this. So from our expansion, we know this is x squared plus 8x. Remember, 2 times x times 4 is 8x. Plus 4 squared, which is 16. Plus 15 squared. 15 squared, we know what that is. It's 225. Plus 225 equals to 289. Okay? So this kind of looks like a quadratic equation, but let's get everything over to one side. So we have one side equal to 0. So in other words, we have x squared plus 8x plus 16 plus 225 minus 289 is equal to 0. Okay? So let me just do this here. This should be negative 64 plus 16 would be, I think it's 48, yes. So this ends up being x squared plus 8x minus 48. If you just do this calculation here, you should get minus 48. But now if you look at this again, we can try to factor this. This is, let me just use a different color maybe to help, is we can just multiply the 1 here with that over there, right? So then we get the man method again. Let me just go back to white. So m is equal to negative 48. And a is just the middle term, which is 8. So we got to find two numbers that multiply to negative 48 and add up to 8. So that is 12 and negative 4, right? 12 times negative 4 is negative 48. 12 plus negative 4 is 8. So this ends up being, let's do that again, sorry. So this ends up being, I just need a little bit more space here. So this ends up being, do I have white? Yes, I do. Okay, so it becomes, remember, this splits, the middle one splits, so it's x squared plus 12x minus 4x minus 48 equals 0. Group the first two, group the last two, so x plus 12, and this is minus 4, x plus 12 equals 0. And if you observe, negative 4 times x is negative 4x, negative 4 times 12 is negative 48. So what do we end up with? X plus 12, and what's left over? Because, sorry, x plus 12 is common in both, that's why we factor that out. And what's left over is the x over here, and the negative 4 over here, right? Which is equal to 0. So when you have a situation like this, right, what that means is each of these is equal to 0, each of these brackets. So x plus 12 is equal to 0. So x is equal to negative 12. And x minus 4 is equal to 0. So x equals 4. So we have two solutions. But if we look at our triangle again, right, our triangle was this. Right, this was x plus 4, 15, 17. Now, x cannot be negative 12, because if negative 12 plus 4 would be negative 8, a side cannot be negative in value. So this is wrong. But x plus 4 is right, because if it's 4 plus 4, this side becomes 8, and so therefore that's our solution. Okay? So 4 is the value of x, but 8, because 4 plus 4 is the value of the unknown side. Okay, section 6, our last section. Hopefully we can get through this quickly. All right, so here we go. So here's theta, here's the right angle, here's 1, 2. So across from theta, this is the opposite, right? This is the opposite, and this is the hypotenuse. So we must use, opposite and hypotenuse. So sine theta is equal to half, so theta must be sine inverse of a half, which is equal to 30 degrees. Make sure that your calculator is on degree mode. Calculator should be on degree mode. Okay, make sure it's on degree mode. Okay. Number 2. Okay, so we have it right there. Good. Here is theta. Here is 4. Here is 5. Okay, so 4. So first of all, always identify the hypotenuse, which is this one, right? It's right across from here. So 5 is the hypotenuse, and 4 is the adjacent. So we have the adjacent, we have the hypotenuse, so we must use cos, right? So cos theta is equal to 4 over 5. So theta is cos inverse of 4 over 5, and the answer for that is 36.9 degrees. Okay, let's move to the next one. Okay, and make sure once again that you have degree mode. Okay, I'll probably just say that for each single one over here. So we have theta over there. Okay, once again, we have the opposite this time, because 2 is opposite right across from theta, and 3 is adjacent, right? So this must be TOA, right? So we have opposite, we have adjacent, so tan theta is 2 over 3. So theta must be tan inverse of 2 over 3, which is equal to, or approximately equal to, 33.7 degrees. Okay. 4 is straightforward. Okay, so we have theta right here. We have 5, 12, we have 13. So in this case, we actually have all 3 sides, and we also know that this is a right angle triangle. So in this case, we can actually use any of them. So for example, let's say we pick the 5, which is the opposite, and we pick the 12, which is the adjacent, so we can use TOA. So in this case, tan theta is equal to 5 over 12, and theta in this case is tan inverse of 5 over 12. Which we said is approximately 22.6 degrees. But what if you wanted to use 12 and 13? So that in this case, 12 is the adjacent, right? 12 is the adjacent. 13 is the hypotenuse, right? So we could have used ca. So cos theta would have been 12 over 13. So theta is cos inverse of 12 over 13. And if you plug that in, you will get the same answer. So you'll get 22.6. And just for the last one, say you chose 5 and 13. 5 is the opposite. 13 is the hypotenuse. So that's so. So in other words, sine theta is equal to 5 over 13. So theta is sine inverse of 5 over 13, which is equal, once again, also equal to, or approximately equal to 22.6. Let's do, so that was number 4, now we have number 5, which is, okay, so same deal as before. So this is great. So we have a right angle triangle, we have 4, we have 7, and we have root of 65, and here's the theta. Okay, so now, again, it's a right angle triangle, we have all 3 sides, so we can use any of the ratios. We don't have to stick to one. So we'll just do all 3 again. So let's say, for example, if you wanted to use 7 and 4, right? 4 is the opposite, 7 is the adjacent, right? So you could have used TOA. right? So tan theta is equal to 4 over 7, right? So theta is tan inverse of 4 over 7, which is equal to 29, or approximately equal to 29.7. If we wanted to use 7 in root 65, 7 is the adjacent because it's right next to theta. Root of 65 is the hypotenuse, so we could use cos. So again, cos theta is 7 over root of 65, so theta is cos inverse of 7 over root of 65, which again would have been the same thing, 29.7. And finally, if we want to use 4 in root of 65, 4 is opposite to theta, so that is opposite. Root of 65 is the hypotenuse, so we have sine. So sine of theta is 4 over root of 65, so theta is sine inverse of 4 over root 65, which is equal to, again, roughly speaking, 29.7 degrees. Okay, last 5 questions, and then we should be good to go. All right, number 6. We have theta over here, we have x, we have 2, and we have 7. Now, the x, I drew that just to make sure you don't actually need to solve for x, because we have the adjacent and we have the hypotenuse. Oh, one more thing, this is a right angle triangle. So we don't need to solve for this. It's not needed. We can if we want to, but it doesn't make a difference because we've got an adjacent and we've got a hypotenuse, right? So in this case, the adjacent is 2, right? And the hypotenuse is 7, right? So that's ka. So in other words, we could have just used cos theta is 2 over 7. So therefore theta is cos inverse of 2 over 7, which is approximately equal to 73.4. 7. This was something like that. This is theta, this is 7, this is 8. And I know a lot of people probably started thinking, oh, 7 must be adjacent, 8 must be opposite, so therefore, you use adjacent, use opposite. You're thinking, actually, hold on, let me just do that the other way. So you're thinking 8 is the opposite, 7 is adjacent. Oh, so therefore we must use TOA. But remember, this does not apply because we don't have a right angle triangle, right? There is nothing to indicate that's a right angle triangle. It looks like a right angle triangle, but there's no evidence. So no evidence of a right angle triangle. Right angled triangle. So since there's no evidence, we cannot find theta. So theta cannot be found. Cannot be found. All right. So that was a tricky one. Sorry. So that was a tricky one, but I just wanted to make sure that you paid attention to the information given to you. Okay, let's move to number 8. So number 8. So here was sort of a tricky one. Kind of uses Pythagoras again. So here's x plus 1, here's x, and here is x plus 2, and theta is over here. Okay. So just looking at it, we can't just simply use variables and solve this thing. So we need to find out what x is, right? So once again, we know that this is the hypotenuse because it's right across from the right angle triangle. So let's solve for it. So we have x squared, one side, plus x plus 1 squared, which is the other side, x plus 2 squared. So let's just expand everything. So we have x squared plus the expansion of that is x squared plus 2x plus 1. Remember, 2 times x times 1 is 2x, and that's 1 squared, which is 1. And for this side is x squared plus 4x plus 4. Same logic. 2 times x times 2 is 4x, and 2 squared is 4. Okay, so if we simplify, if we bring everything over to one side, right, let's just simplify this side. So we have like 2x squared plus 2x plus 1 is equal to x squared plus 4x plus 4. I didn't really do anything, that x plus x equals 2x squared. Now if I bring everything over, let me just write this here. So it's 2x squared plus 2x plus 1 minus x squared, right, because this just becomes minus 4x, once again this 4x to the other side becomes minus, and then minus 4, and then this 4 to the other side equals 0, right? So 2x squared minus x squared is simply x squared. 2x minus 4x, 2x minus 4x is simply minus 2x, and 1 minus 4 is minus 3. Okay? So what we need to do here is we need to factor. Okay? So if we're going to factor, again, remember, we take the 1 here and we multiply with that one there. So m is equal to negative 3. A is equal to the middle term. Sorry, should have done that. So a is the middle term, which is negative 2. So we got to find two numbers that multiply to negative 3 and add to negative 2. So those two numbers are negative 3 and 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So remember, the middle term splits. Okay, I'm just going to go back to white for a second. The middle term splits. So we get x squared minus 3x plus x minus 3 is equal to 0. Got to group the first two, group the last two. So we group the first one, x comes out, x minus 3. There's nothing in common here, so we just take the same sign and we take 1 because that's always the common for everything. X minus 3 equals 0. Okay, so I just moved down a bit. And since these two are common, we get x minus 3, x plus 1, right? This x plus 1 equals 0. So x minus 3 equals 0, because that's what this means. This is equal to 0, and so is that. And so therefore x is equal to 3. And then x plus 1 also equals 0, because x is equal to negative 1, right? So now let's look back to our original triangle, which I'll just redraw it here. So we have x plus 1, x plus 2, right? X cannot be negative 1 because this side cannot be negative, so this is not an answer. So x is equal to 3, okay? So what that means is, we still haven't solved it, so what that means, since x is equal to 3, our triangle now is 3. This is x plus 1, so that must be 4. This is x plus 2, so that must be 5. And our theta, where was our theta again? This was our theta, right? So we can use any of the trig ratios. I'm just going to use one, okay? So let's just use sine because I like sine. So the opposite to theta is 3, right? The hypotenuse is 5, so we're going to use sine. So sine theta is equal to 3 over 5. So theta is equal to sine inverse of 3 over 5, which is equal to, what is it equal to? So approximately equal to 36.9. Whew, long solution for one problem. But let's just go back to sort of revisit how we did it, right? So we had to first find out what x was. It was sort of a long, lengthy process. We got to like some factored form, and each of these is equal to 0. So x minus 3 is equal to 0, so is x plus 1 equal to 0. We solved for each of them, and so then we figured out what our triangle was, and then we just came back to SOH-CATOA. I just used SOH to solve for this. All right, number 9. Okay, there are two ways to do this. I'm just going to do the easy way, okay? And the long way, I'm pretty sure you can figure out. It was pretty much the same thing as the previous question, but I'm just going to do the easy way. So here's 7, here's 2x, and here's 3x. So here's the easy way, okay? So you might be tempted to think that, oh, I have to figure out what x is. But here's the thing. Imagine if we just use 2x and 3x for example. So 2x would be opposite, right? 2 is right across from theta, and 3x is the hypotenuse because it is, right across from the right angle, right? So so we're going to use SOH. In other words, we're going to use sine. We have opposite and hypotenuse. So sine theta is equal to 2x over 3x. Now the beauty of this, if you can see it, is since it's 2 times x and 3 times x, the x's can cancel out. So what are we left with? We are just left with 2 over 3, which is perfect. We don't even need to find out what x is. Right? We can immediately figure out what the angle will be. So, since sine theta is equal to 2 over 3, theta is equal to sine inverse of 2 over 3, which is approximately equal to 41.8 degrees, and that's our solution. Now the hard way would have been to do Pythagoras, 7 square plus 2x square equals 3x square, and then we could have found out what x is, and that's just a big lengthy ordeal which I'm going to avoid. The easy way is just recognize that if you just have the x's, you can cancel them out. In the previous question where we had x plus 2, x plus 3, we could not cancel them out, right? You cannot, if you have, say, x over x plus 1, you can't cancel the x's. That just does not work. That just does not work. So that's why we had to solve for the x in this situation. But in this case, the x's canceled out, so that made it nice and easy, and so we could solve for that. Finally, number 10, if you've done number 7 already, this should be straightforward. But if we look at that, right, here's our theta, here's our 2, here's our 5, right? Once again, this is not a right angle triangle. There's no evidence right here. There's no right angle right here, right? You might think it's here, but it's not. I haven't shown it. So there's no evidence. So therefore, this is not a right angle triangle, not a right angle triangle. So theta cannot be found. Cannot be found. And that's our solution. All right, I hope that helped. See you in class. Bye.